Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we are looking at this Maths Olympiad question. Let's look at how we can handle this together. Trust me, Maths Olympiad questions are very easy, but you have to understand the logic behind it. Let's look at how we can handle this question together. The question reads: if the sum of two positive numbers is 8 and the sum of their cubes is 20, what is the sum of their square? We are looking for the sum of the square of those two numbers. Let's write down the solution. Let's write down the solution. From here, we can say the two let the two positive numbers be x and y. Let the two positive numbers be x and y. From the first statement, if the sum of the two positive numbers is equals to, the word is here, it means is equals to 8. Then it means x plus y will be equals to 8. We can call this equation 1. Very important. And the next question now says, and the sum of their cubes is 20. Sum of their cubes. It means cube means we take the cube of x, that will be x cube, plus y cube will be equals to what? 20. We can call this equation 2. The question now says, what is the sum of their square? From equation 1, we can square this, both the left hand side and the right hand side, because we are looking for the sum of their square. So it means by the time we square equation 1, we have x plus y all square will be equals to 8 square. And this is the same thing as x plus y all square equals to 64. Let's expand this. By the time we expand this, we square the first time, that's x squared, square the second time, that's plus y squared, then add these two, then multiplied by 2, that will be 2xy, will now be equals to 64. Let's call this equation 3. Again, from equation 2, we have to recall the sum of 2 cube. The sum of 2 cube. If we have x cube plus y cube, this is the same thing as x plus y, then x square plus y square minus xy. Very important. This is an identity. Okay, so we need to replace the entire expression here with x cube plus y cube, and we'll have x plus y into x square plus y square minus x square will now be equals to 20. Let's call this equation 4. Very important. From here, we can as well work on this. Okay, we have done that. We have equation 3, equation 4, equation 1, and equation 2, respectively. We are asked to find the sum of their product. Sum of their product means we are looking at x squared plus y squared. That's what we are looking for. Here, let's do some substitution. Let's relate equation 4 to equation 1. We have x plus y, which is 8. In place of this x plus y, we can replace 8. So that we have 8, or we can say put x plus y equals to 8 into equation 4. Into equation 4. What are we going to have? Let's clean here. Let's remove the question. We're looking for the sum of the square. What we're actually looking for is x squared plus y squared. That's what the sum of their square. The sum of their square. When that's x squared plus y squared. Okay. So we'll have 8 now into in place of x plus y, now we're replacing 8 into x squared plus y squared minus xy will now be equals to 20. Let's divide both sides by 8. Divide both sides by 8 such that x squared plus y squared minus x squared will be, if we reduce this, we'll have 5 divided by 2. That's 4 here, 5, then 4 here, 2. Let's call this equation 5. Very important. Okay. Uh, at this point, if we check this very well, we can take this 2x squared to the other side from equation 3 now. From equation 3, let me clean this. From equation 3, we can deduce that x squared plus y squared will be equals to 64 minus 2xy. Let's call this equation 6. And in place of this x squared plus y squared in equation, we can substitute equation 6 into 5 such that, let's move here, such that we'll have, in place of x squared plus y squared, we'll replace it with what? 64 minus 2xy. Okay? So we can say put equation 6 into equation 6 into equation 5. So in place of this x squared, we'll replace it with what? It will now be 64 minus 2xy minus xy will be equals to 5 divided by 2. Very important. Okay. Let me remove this. Here, we can rearrange this as, let's bring this and take this to the other. We have 64 minus 5 divided by 2 will be equals, by the time we take this, we have 3xy. Very important. Okay. Let's work on, I think I can clean this side. Yes. Let's work on this. Let's find the LCM. The LCM is 2. 1 into 2 is 2. 2 times 64. That will be 8. 128 minus 5 will now be equals to 3xy. Let's subtract. When we subtract this, what are we going to have? We have 123 divided by 2 will be equals to 3xy. Our m is to find xy now. Let's multiply both sides by 1 over 3. 1 over 3. Very important. 3 here, 3 here. We'll be left with xy now will be equals to, can we reduce this? Yes, 3 can go. 3 here, 1, 3 here, 4, 3 here, 1. That will be 41 divided by 2. Let's call this equation 7. So xy is equals to 41 divided by 2. So you realize that we can plug this back into, let's check equation. We can plug this back. Yes, we can plug this back into equation 5 since we are looking for x squared plus y squared. So in place of this, yes, in place of this xy, we can replace 41 by 2 so that we can find xy. So let's substitute. So let me remove here. We can say put equation 8 into equation 5. We have x squared plus y squared. In place of this now, we'll have minus 41 by 2 will now be 5 by 2. Our m is to find x squared plus y squared. So x squared plus y squared now will be 5 divided by 2 plus, when this minus 41 divided by 2 cross the equal sign, the sign will change to positive 2. So finally, we are asked to find the sum of their square. So the sum of their square now will be 5 divided by 2 plus 41 divided by 2. We have monomial denominator. The denominator are the same, so we can easily add the power. Then pick one of the denominator. We'll add this 41 plus 5, that will be 46. We'll pick one of these two. Then x squared now plus y squared will now be equals to 2 here 1, 2 here 2, then 2 here 3 will now be 23. So the sum of their square now, which is x squared plus y squared, is nothing but 23. So this will say to be the solution to this question. Thank you for watching. Please do share this to your learning colleagues, and don't forget to subscribe to TJ Smart Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.